Okay, so, in the last class we looked at circumscription, and today let us look at an application where circumscription has been used, and this application is something that we have seen earlier, which is the event calculus. So, in some sense we are revisiting it. At that point we had not really discussed how to do the inferences here, but today we will look at that essentially. So, if you remember, event calculus is reasoning about change, or how actions change the world essentially. So, if you remember, in event calculus there were three sorts of arguments. So, the word sort is used as a synonym of type essentially in the logical community. So, when you say many sorted logic, you mean a logic in which there are different types of variables. So, for example, you could devise a many sorted logic in which you say this is a type human, this is a type animal, and so on. So, instead of having to say that x is a human and then say all humans are mortal, for example, you could simply say that x comes from this type human. So, it is like a namespace where only certain names are allowed for humans, and then you could simply say mortal x and you are done with it kind of thing. So, the event calculus uses three sorts of things, and it is a one was events, and we will use these Greek letters alpha and so on for events. So, let us say alpha 1, alpha 2 and so on, and then fluents beta 1, beta 2 basically, and then time tau 1, tau 2 and so on. So, there are these three different kinds of things essentially. So, essentially we do not have to say that alpha is an event anymore or beta is a fluent anymore. We will accept that if a name comes from the fluent namespace, then it is a fluent. A fluent is essentially a predicate which can change essentially. So, it can be for example, the water is hot or the water is not hot. So, it can be true or false at different times essentially. So, any predicate which can change is a fluent essentially. So, you can say I am holding the pen, I am not holding the pen, all these sorts of things essentially. Now, if you have something like an event calculus, what can you do with it? So, this is a logic machinery. Okay. So, there is a paper by Shanahan, it is called event calculus explained. And it is a kind of a tutorial on event calculus. We will put it up on the website, but you can just go to the web and you will find it. You just look for Shanahan and say event calculus, and this is probably one of the first things that you will come up. So, some of this description is given in this paper essentially. So, this logic machinery can take different kinds of inputs and arrive at different kinds of conclusions, or it establishes connections between different kinds of things. So, one kind of thing is tells you which events are happening. So, John went to the canteen, he did something and he did something, all these are events, and so there is a narrative essentially. that these events or these so we will use the term events and actions interchangeably. So, these actions happened or these events happened essentially. Then we have what actions do essentially. So, in some sense this is a domain description. So, for example, you might say that if you pick up a book from the table, then you are holding the book, that is the effect of that action essentially. So, this is the kind of thing that planning community talks about all the time essentially, but this is a domain model of what is the relation between, we are trying to find relations between, event calculus is trying to find relations between events and fluents essentially. How do events affect the world, changing world essentially. And at which point what fluents are true essentially. So, if there is a sequence of things which are happening, you should be able to say that at time t 1 this was true, at time t 2 this was true, or if you just ask a query as to what all was true at time some t 7, you should be able to answer that question essentially. And one can move from any two of these to a third one. So, we are interested here in the movement from the left to right, which is that given a narrative and given a domain description, we want to figure out what is true essentially in the world essentially. But you could do other things essentially. So, for example, given a domain description and given what is true when, which you kind of slightly twist and say what do you want to be true at this time, which means that what is the goal that you want to achieve, then the task is to find what events should happen, and that is a task of planning essentially. You say that you know what is the effect of actions, you know what the world should be like. So, what are the actions that you should do for the world to become like you want to do, and that is the task of planning. And likewise, there is a third task, if you know what happens when, that these are the events which have happened, and if you know what is true at the current point of time, then you can sort of learn as to what are the effects of actions essentially, or you can learn a domain model by observing the real world actions and the change that it creates essentially. So, we are not interested in that, we are interested more in the deduction part here, or post diction as some people call it, that given that some things have happened, what can we predict about what is true now essentially. So, let us look at the event calculus predicates. So, EC stands for, and we had mentioned these before. So, I will just do them quickly again. Initiates, alpha, beta, tau essentially. And the meaning of this was, if alpha happens at time tau, then beta becomes true. Actually, it becomes true after that time tau, but we will not go into the smaller finer details of this. If you are, so you can work with either discrete time or continuous time. So, the simpler one is the discrete event calculus, discrete time event calculus, in which time goes in numbers, time 1, 2, 3, 4 and so on. And essentially the semantics of this initiate statement is that if you do something at event at time t, then at time t plus 1 beta will become true essentially. That is a small point which I am just mentioning in the passing essentially. Then we have terminates alpha, beta, tau, which is just the opposite of initiates. Instead of true, it becomes false. So, if you put a book down, then you are no longer holding it, for example. Then there is a predicate called initially, So, at some true beta is true at the initial point. So, whatever it is time, let us say tau is equal to 0. So, we are talking about discrete event calculus. So, initially beta is true essentially. Then happens alpha time tau, it simply says alpha happened at time tau. So, this is part of narration. It is saying that some event has happened essentially, and then if that something alpha is that has happened, and if it is affecting the world, then you have to look at the initiates or the terminates predicates to decide as to how has it changed the world essentially. So, you are explicitly saying that it has happened. Then we have holds at beta at time t. So, this is essentially saying that beta is true at time tau essentially. And then we have one thing which is actually a short form, and this is logically equivalent to saying that some event has happened So, clipped is just a short form for a more complex sentence. It says that there is some event alpha which happened at a point tau, which is between tau 1 and tau 2. So, somewhere between time t 1 and time t 2 an event happened, and the effect of that event is that it terminates beta. So, clipped beta between t 1 and t 2 is just a short form for saying that something happened which made it false without naming really what happened. So, we are simply saying that it became false somehow, some event happened and it made it false essentially. So, we have two inferences we can make. One is that holds at a fluent at time t if it was true and not So, one way we can conclude that a fluent f is true at time t is that if it was initially true to start with and nothing has made it false essentially. And another way is is to say that something happened another way that something could be true at a given time t is that something happened before that which initiated it or which made it true, and nothing else happened which made it false along the way essentially. So, some action A happened, if you know that A happened and you know that A initiates this fluent f and this happened before this time t, and somewhere from this time t to t nothing else happened essentially. Yeah.
Why do we need T2 here? We can just say that it was not kept between T1 and T.
Yeah, actually that is what we use. So, in fact we do not need. So, this is a subset of the event calculus that we are interested in, and we will just call this as SC, which stands for simple calculus. So, this set of statements including the clipped statement, we will call it as a simple event calculus statement. These are the rules of the language that allow us to make inferences essentially. So, now we are interested in something called the frame problem. Which essentially says that how does one cater to unstated effects of actions and unstated events to conclude what is true. So, this is a frame problem. This is originally due to McCarthy, and Hayes, Patrick Hayes. So, they raise this problem that if you want to reason about change in the world, how can you conclusively say that something is true essentially? It is like saying that let us say you kept a book in your on the table in your hostel room, and then you came here to attend this talk, and then when you go back you want to open that book and read it again. How do you know that the book is still there essentially? How can you conclude that the book is still there? And this is basically the problem we are facing with incomplete information, that we are not living in a world which is where we know everything about what is happening. If it was a closed world, then of course you can say that because it was not stated, it did not happen. But in a real open world, how can you come to such conclusions? So, you can see that this is very similar to the problem of default reasoning, in a sense that when we said that P t is a bird, how can you infer that Tweety flies essentially? Because you don't know everything about Tweety. Tweety could be a penguin, Tweety could be dead, Tweety could be in a cage, but it is reasonable to make inferences. So, you can see the connection that we are making here, that one of the approaches to solving the frame problem was through posing solutions through circumscription essentially, and that is what we are trying to study here essentially. So, we will look at a particular example which became quite famous, and it is called the Yale shooting problem. Which was given by I think Hanks and McDermott. So, the basic idea of the Yale shooting problem is you load a gun, then you shoot, so they talk about the turkey. So, I will also talk about a turkey. So, at some point T1 you load a gun, at another point T2 which is after T1 you shoot, and then at a third point T3 which is after T2 is the turkey dead essentially. So, this is a Yale shooting problem, which is very similar to what I was trying to describe to you. How do you know that this has happened essentially? So, let us look at a simple formalism of this problem in a simple event calculus and see how can we arrive at a conclusion essentially. What are the things that we have to be wary about when we talk about this essentially? So, how do we model this problem? We model it as follows, that there are some actions load, sneeze and shoot. So, there are three actions, and fluents, loaded, alive and dead. The relations are initiates, load, loaded at time t. So, we are describing the domain, and we are saying that the effect of the load action is that loaded becomes true. So, implicitly we are talking about a gun here. Then shooting will initiate the predicate dead, which means dead will become true, provided the gun is loaded. No, this is just a domain theory. This is not the narrative essentially. So, we are simply saying that the effect of load is to that loaded becomes true at whichever time it happens, and the effect of shoot is that dead becomes true essentially. In the full event calculus, we do not need both alive and dead, but here just for the sake of completeness we will write this. If the gun is loaded, the shoot action will terminate alive essentially, just to illustrate what is the meaning of terminate essentially. So, this we will call as the domain model, and we will use the symbol sigma for this essentially. And then in some sense the story. Initially alive is true. Happens load at T1, happens sneeze at T2, happens shoot at T3, and T1 is before T2 and this is before T3, which is of course greater than 0 essentially, or T0. This is a story that initially the turkey was alive, then you loaded the gun, then you sneezed, and then you did the shoot action. This we will call as, this is a narrative, and we will call this delta, this set of formulas which are describing what happened essentially. The question we are asking is that given sigma and delta and the simple calculus that we defined, which basically talked about the effect of when does some holds that becomes true. Is it the case that holds at dead T4, and let us say we are given this time point T4 which happens after the shoot event. So, that is a question that we are trying to answer, that we know that the effect of what is the effect of those actions load and shoot. We have not said anything about sneeze, but then we know that initially the turkey was alive, then we loaded the gun, then we sneezed, and then we shot. After that, is the turkey dead? True. The problem is there are various problems. Is sneeze same as shoot? We do not know. If you want to explicitly state that they are different, then we must either state explicitly they are different, or we must say universally that there is a unique name assumption which says that all names refer to unique entities. This is a problem that we often face in logic. Essentially, we never know whether two terms refer to the same, are mapped to the same element or not, or in this case two actions are mapped to the same action or not essentially. Then is it the case that sneeze terminates loaded? How do we know that the sneeze action does not terminate the loaded predicate essentially? We have not stated anywhere, but how do we know that? Remember that we are not working in the closed world environment, we are simply saying that this is what is stated and what is reasonable to infer essentially. So, obviously, the solution that we are trying to drive at is that it is reasonable to say that that this is not the case, but how do we say that in a logical framework where a logical inference system is able to arrive at the conclusions essentially. So, I will stop here in this class, and in the next class we will take this up from here, and we will see that how circumscription comes to the rescue here essentially. So, essentially we will say that these are the only effects of actions and these are the only events that happened. If that you assume, then yes, you can infer that the turkey is dead. And so, we will stop here and we will take it up in the next class essentially.